I'll go back, now I'm worried that I put 0.5 when we calculated these. But no, the numbers make sense though. So I'll double check them, but I'm being careful right now, okay? Plus 0.1 Okay, so ZX at 0.5, I am getting 0.372. So I'm just gonna do second entry, and I'm gonna go change my 0.5 to 0.75. Quicker to do if I had a regular calculator. Y at 25.5, Z sub Y at 75.25. So, actually, I could do the second one first, and I could just go in and change my coefficients. Is multiplying y, so the y was 0.25, and 0.5 is multiplying x, and the x was 0.75. And then, does anything change the bottom? No. So, enter, oh no, that was this one. Alright, and then, let's see, without retyping the whole thing, but I gotta make sure I'm changing the right things. Okay. Okay, so it's 0.5 times x, and x is 0.5, that's 0.2 times y, and y is also 0.5. Alright, why don't we just pick one of them and write a sentence about it. Keep in mind that, like, this derivative is gonna read kind of funny, because you can't really hold one constant and change the other one, because they relate to each other. But technically, interpreting the slopes, like if I just pick this one, okay, they just call it, I know it measures the volatility, but they're just calling it the standard. The standard deviation of this portfolio increases by 0.2 .2793 when asset one, oh, you know what, actually, this is there's a good point to make. I'm going to I'll explain why I did that, okay?
I was watching Hillary cough up Green Dude website. She's like the best or something. I mean, that's what I told her. It's on the internet. I must be sure it's gotta be.
Okay, this comes up every once in a while in interpreting derivatives.
Have you seen it?
Technically, this value was .2793 per one, but think about our x and our y. The two of them are proportions in between 0 and 1. So it's not gonna make sense to increase one of the assets by 1. Increasing it by 0.1 makes more sense. So this ratio is equivalent to this ratio. If I divide the denominator by 10 and I divide the numerator by 10, it still keeps the ratio the same. And so I could say the standard deviation increases by 0.03 almost, so 0.02793, when asset one's proportion increases by 0.1. It makes more sense than saying it increases by 1, because the two x and y added together can't add up